Today we are going to talk about piecewise functions. By the end of this video, you should be able to evaluate and graph piecewise functions. First, let's write the definition for a piecewise function. A piecewise function is a function defined by two or more equations. Each equation refers to a different part of the function's domain. So here we have an example of a piecewise function. We have f of x equals 3x minus 4 if x is less than or equal to 3, and 1/2 x plus 1 if x is between 3 and 9. So we have two different equations, and this second part here, the if part, tells us when to use each equation. So I always look at this part first. So if x is less than or equal to 3, we use the first equation. If it's between 3 and 9, we use the second equation. So let's practice evaluating these. If we want to find f of 3, we need to look at 3 and decide which equation to use. 3 is less than or equal to 3, so we're going to use the first equation. Just plug in 3 for x, and then evaluate it. We end up with 9 minus 4, which is 5. If we're looking at f of 2, we need to look and see which equation do we use. Is 2 less than or equal to 3, or between 3 and 9? Again, this one is less than or equal to 3, so we're going to plug 2 in for x in the first equation. So we have 6 minus 4, which is 2. Then we have f of 5. Is 5 less than or equal to 3, or between 3 and 9? It's between 3 and 9, so we're going to use the second equation and plug 5 in for x. So half of 5 is 2.5, plus 1 is 3.5. And lastly, we have f of 10. Now, 10 is not less than or equal to 3, and it is not between 3 and 9. So this function does not tell us what to do with numbers that are greater than or equal to 9. So for 10, this function does not exist. Now let's look at some graphing examples. This first equation says if x is less than 0, we're going to use negative x plus 1, and if x is greater than or equal to 0, then we use 2x plus 1. So the way that I like to do these is by highlighting. I'm going to make my first equation yellow and my second equation orange. So the first equation applies if x is less than 0. So I'm going to highlight that section of the graph. So that would be the left side of the graph. I'm going to color that yellow. Then I'm going to color where x is greater than or equal to 0 orange. So I am only allowed to graph the first equation where the graph is yellow and the second equation where the graph is orange. Now let's go back to Algebra 1 and remember some things about graphing equations and inequalities. Most of these equations are given in the form y equals mx plus b, where m is your slope and b is your y-intercept. Another thing to remember is that when we graph inequalities, and we talked about this at the beginning of the year, if you have less than or greater than symbols, you use an open circle. If you have greater than or equal to or less than or equal to, you're going to use a closed circle. Now let's look at how to graph this. The first equation is negative x plus 1. So that means our y-intercept is going to be 1 and our slope is negative 1. But since this says if x is less than 0, I cannot put a dot here on my y-intercept. I need to put an open circle. Then usually we go down 1 and right 1 to do a slope of negative 1, but we can't graph that direction into the orange section. We need to go up 1 and left 1 to stay in the yellow section. Then we can connect our dots. Then to graph the second equation, 2x plus 1, so our y-intercept is 1, and since our function is defined for when x is greater than or equal to 0, we're going to use a closed dot here. And then our slope is 2, so we go up 2 over 1 and connect the dots. So that's the graph of our first piecewise function. Let's look at the next one. So if my first equation is the yellow equation, so that is when x is between negative 4 and 1. Then my second equation is when x equals 1. I'm going to make that my pink equation. So when x equals 1, that's just here. And then the last one will be my orange equation. And that is when x is greater than 1. Now let's go ahead and graph. So my first equation is x plus 3, so my y-intercept is 3, and my slope is 1. So I'm going to go up 1 and over 1. Then I have an open circle here. If I go to the other edge, since it is less than or equal to negative 4, I can put a closed circle here. And then connect the dots. Now, the second equation is kind of a weird one. When x equals 1, then y is 3. This is just a point. The point 1, 3. Then the third equation, when x is greater than 1, my function is just 2, which is a horizontal line. So since it's greater than, I'm going to have an open circle, and then it's a horizontal line. Let's look at another example. So if x is not equal to 0, that'll be my yellow equation. So that's everything except the y-axis. And then the second equation, when x equals 0, so that is just the y-axis. Now, for my first equation, I have y equals 2x, so my y-intercept is 0, but I can't put a point on the y-axis because that's not shaded yellow. So I'm going to put an open circle, and then my slope is 2, so I'm going to go up 2 and over 1. Then for the orange equation, if x is 0, then y is 1, so again, that's a point on the y-axis. One last problem. If x is less than 0, I'm going to shade that yellow. And then if x is between 0 and 4, I'm going to shade that orange. So my first equation is 2x squared. So this is going to be a parabola. I'm going to think of this as a parabola in vertex form, where my vertex is 0, 0. So I'm going to put an open circle at 0, 0. And then I'm going to think about the pattern for quadratic. Since a is 2, I'm going to go over 1 and up 2, and then over 2 and up 8. Then my second equation is y equals 1. So that is going to be a horizontal line. Since I have a less than or equal to symbol at 0, that'll be a closed circle. And then I have just a less than on the other side, so that's going to be an open circle. And then a horizontal line between them. So piecewise functions can include linear functions, just points. They can include quadratics, cubics, any type of equation that we've talked about so far this year. But I think it is most helpful to shade in the different parts of the domain, at least for the first few problems until you get more comfortable with these type of problems.